Hello, everyone. Welcome to another Pips Talk. Our today's guest is Alex Turner, and Alex is a new postdoctoral researcher at the Center of Human Compatible AI. He recently received his PhD in computer science from Oregon State University and is currently focused on solving the alignment problem, in particular examining the assumption made by the field and studying empirical data on how general intelligence form their values. Welcome to the talk. And Alex is joined here today with his colleagues Logan Smith and Quentin Pope, who are here to help him answer any questions that you might have. And feel free to ask questions anytime during the talk, either in the chat or raise a hand, and we will get to you. And as usual, the talk will be maybe about an hour and discussion will follow. The talk's name is The Shard Theory of Human Values, and Alex, the floor is yours.
Thank you so much. And we can, feel free to ask questions during the talk, raise your hand or say something in chat, and then that'll get flagged and I can answer it. I do anticipate this. It possibly could be a shorter talk of like 30 to 35 minutes, or it could be like longer, depending on like how many questions get asked during it. All right, can we see my screen?
Yes.
Great. So I'm going to be talking about the so-called shard theory of human values. I'll be presenting all of this. I've been working with Quentin Pope on this for a while. A lot of the original ideas and a lot of the thinking is his. And I've also been working with Logan and some others on this as well. So there's a couple intuitions which got me really interested in this theory, which is both AI and also has a lot to do with neuroscience because it has to do with human beings. So one intuition is, well, we've got this AI alignment problem. We're going to build really smart machines, but it seems like when we build them, the world is going to change very rapidly. And if we haven't built them correctly, if we haven't motivated them properly, they might be the last machines we ever build. So it would be super, super convenient if we actually had a lot of data about AGIs. And I think there's really good news here because, in fact, we do have a lot of data about certain, not artificial intelligences, but about general intelligences. That human beings provide this huge amount of evidence about alignment that I think has been really under focused because often we think about people, it's like, wow, people are really messy, something slapped together by evolution. And I think this actually turns out, in terms of human cognition at least, is mostly not true. Not in the ways that we'll care about for alignment. And so I think there's a lot of fascinating insights to be had by thinking carefully with a modern understanding, looking at what the human learning process is, looking at what human values are, how they form, why people care about like candy and their friends. Like there are in fact explanations for this. Because humans actually care about their friends, there has to be like this like reliable causal explanation for what is happening in the human brain, which makes them act in this way. And so also humans have some pretty good alignment properties. Obviously humans are aligned with humans, but that's not what I'm pointing at. There's people tend to care about specific predictable kinds of objects in reality, not like the corner of like an oak table or something. Like very few people, I think probably no people have like most of their values centered around that. And I mean, when you have a kid, it's not like, wow, I wonder what my kid will value in this. Like you do probably wonder what your kid will value, but within kind of a set of predictable outcomes, and not like they'll value like the corner of an oak table. So this seems like maybe, well, sure, we know kids won't care about oak tables, but I think this is quite important because it hints at a predictable mapping between the things which go into making a human be motivated and the things which humans are actually motivated by. And since we want to understand this mapping for AI, like how do we design an AI's training process, reward process such that the AI reliably cares about certain kinds of objects, like people or certain other things. This is actually very important to understand. So I think that this is actually an extremely important hint that people have this predictable kind of like way in which they care about specific things. That people also are pretty good at what's called navigating an ontological shift. So an ontological shift is basically you start off thinking, gee, the world is made out of animals and objects and people and cars and trees. And then you go to school and you learn about atoms and you learn about cells. And like a kid who, like, there's some kinds of AIs that we can write down the math for, and they do not do this very well. That when they go from thinking the world is made out of objects to thinking the world is made out of atoms, and now they don't know how to find any value in the world anymore. So obviously this doesn't happen to people, maybe in some like pretty mild ways. Like a person might have a crisis of faith, and they might be like, I used to believe in God, and I thought that's where the value, like all the value in the universe was, and then they get confused. But by and large, people are pretty good at this. That kids do not stop caring about animals, and like a physicist still cares about her family after learning about quantum mechanics, even though she can't like express that her preferences about her family in terms of the wave function. That's okay. Somehow this still works anyways. So there's these good things that humans manage to pull off, and then there's a question of why. And the nice thing about asking questions about people is they exist, and so there's a guaranteed answer as to why this happens successfully. I'll pause for a second here in case anyone has a question. Great. So there's human value formation. There's many tomes written on what is good and moral and what people care about, and I'm mostly going to not think about those for this talk, or not talk about those. And instead, just focus on the fact that you, as a person, there are like introspectively observable influences on the way you make decisions. You might pass by a candy shop and be like, there's some part of me that is maybe wanting to go get candy, or at least you notice yourself getting candy more often when you go by a candy shop. So there's these contextually activated lines of cognition, which affect what choices you make. And then there's a question of, how does this get there? Does the genome somehow hard code a lot of preferences that we have for each other, for the activities we engage in? Is it learned? How is it learned? And while people don't usually think about their sweet tooth as one of their values, I think it has the same type signature. And I'll talk about it because it's relatively easy to talk about. We don't have to get into like philosophical debates about what is good or not. And we can focus on the simpler story of, well, how did this candy urge get there? And then I think understanding the simpler cases has been helpful, at least for me, for thinking about what people usually think about their values, like caring about their friends, like honor and so on. So the shard theory of human values is trying to understand a single ever example of general intelligences forming values, at least the single ever one that we know about. And in order to answer this broader question I hinted at before of how do outer optimization criteria like reward circuitry in the human brain, like rewards that we give an AI during training, what kind of inner cognition will this create within the AI? That's the question we ultimately want to answer, because we want to create good cognition that will be aligned with human preferences or make a good feature for us in some way. And so because all we really have access to is, we can specify this, we can reward the agent when it makes people smile. It's like, well, what kinds of cognition does that create within the agent when we do that? And so I think this is pretty relevant for answering that question, because we can just look out and try to interpret what we see. So for this talk, I'll be making 3 neuroscientific assumptions, and I want to flag that I'm not like a neuroscientist or an expert on this. I've done some reading, but this is like where I would definitely most appreciate feedback or additional information. So first is learning from scratch, which claims that basically the neocortex is roughly randomly initialized at birth, while things like the brainstem and hypothalamus, there's circuitry that is like hard-coded by the genome, like automatic breathing regulation is one example of that, and there's like a lot more. So the claim is not like the whole brain is learned from scratch. That would be, like what would be doing the learning in that case, but rather the neocortex and like the human's eventual abstractions, that there's not, in fact, this would claim that there's not, in fact, something like a social module that evolution put into us, and then like a problem-solving module, and like a math or like an abstract reasoning module, but rather is a random initialization, and then whatever we see from people is guided by the rest of the hard-coded circuitry. The second assumption, I think, is basically predictive processing, which is so if light impinges on like your retinal ganglion cells, and like you see something, and then that goes up through the optic nerve. It goes back to your occipital cortex, and there's these feed-forward connections that are passing along the information, but also feedback connections, which are predicting future activations. So there might be a prediction that in a moment I will see a cat. And if you don't see a cat, this would be a predictive error. And then there'd be some learning that would modify that. So you would be less likely to make that mistake the next time, is my understanding of how this roughly works. And then third, that there is a reward system, and that the brain does some kind of reinforcement learning, where some circuitry activates and reward is released. It could be reward predictive error. And then basically there's credit assignment, which means that the computations of the brain, or the thoughts that the brain judge are responsible for producing the reward, would be reinforced, would be generalized in some way. I'm not committing to like the kind of reinforcement learning that happens or that it's specified, but just that there's some kind of reinforcement learning, and also probably some genetically hard-coded reward circuitry. But I actually don't have a very good idea of what this might be, and my impression is that there's not much known about what like subcortical circuitry is actually hard-coded, and this seems like an interesting question to me. So if anyone has more information on that, especially later in the talk, I'd love to hear about that. So these are the three main like neuroscientific assumptions that the theory currently makes. My understanding is that they're reasonably mainstream, but not necessarily universally agreed upon. And so, okay, actually, I want to pause again and see if anyone has comments before we move on. Okay, so given these assumptions, there is one inference I think we can make quite immediately, which is something called information inaccessibility. So in AI alignment, there's for I think a couple years now, we've had this idea that there's a certain kind of task which is hard, and here's the kind of task where we might train an AI model on video sequence prediction. It's looking at videos in nature, it's learning to predict the next frame given all the previous frames of the video. And maybe the AI gets really good at this, and suppose that somehow it's representing what we would call a tree concept within the activations, or within its circuitry. And we want to specify somewhat, like we want to figure out when the AI is thinking about trees. Now, obviously for alignment, we want to more think about, well, is the AI thinking about bad things like killing people or deceiving us? But for simplicity, suppose we want to know when the AI is thinking about trees. Now, even if the AI has a tree concept, information inaccessibility says, well, this is probably inaccessible to us, that there's no simple procedure that we can write down beforehand, no simple algorithm which will just check whether the trained model is thinking about trees. Now, there's several reasons why this might be hard. Even though you have a fixed architecture in which different weights will be trained and you'll get a different trained network, and even though you might know that there's going to be a tree concept, you don't know where in the network the concept will be located. You don't know how it'll be encoded relative to other concepts. And so because there can be different representations, different locations, different encodings, this might change on an architecture by architecture basis, on a task by task basis, that information inaccessibility is like, look, there's probably not a simple procedure. This is my understanding of it. And so we should expect to either have to do a lot of work to like understand, to do interpretability on this network and understand how it thinks in a sense, and build up just like what is the algorithm it's implementing and understand it in a very deep way. Yes, then we could probably know when it's thinking about trees. But because networks could be very large, this could just be ridiculously hard. And I think by default, I don't expect us to be able to do things like this for any kind of sophisticated concept. And so it's not that it's literally impossible, but that this is really hard relative to, like, we could access, does the AI output the correct prediction for what frame will come next? And the AI we can just run the model and access that information. So that information is accessible to us. It's just a direct output of the AI. So essentially, we can't access information in the AI's learned world model. And so I call this, I say that the AI world model is inaccessible to the designers. Now, according to learning from scratch, we can then infer that the human world model is also inaccessible to the genome for the exact same reasons, that people will not learn, like different people in slightly different conditions, even with the same genotype, will not necessarily learn the same representations, the same abstractions, that their abstractions will be in slightly different areas, maybe with slightly different encodings. And so for the same reason, the human world model also seems just inaccessible to the genome. And as a consequence, I think that like a lot of the things we think evolution can just do, like figure out when you're thinking about betraying someone, and depending, like if it's an advantageous situation, it'll influence you to do that, and otherwise it won't. And I think this just like sounds impossible, because like at least not literally impossible, but like very, very, very unlikely due to information inaccessibility, that the genome can't figure out when you're thinking about like whether you like sunk cost. Like I think it's very unlikely that sunk cost, where you've committed on a project for a while and it would be wise to just cut it off, but you've already put so much into it, and so people have this bias to keep on going. I think the genome cannot hard code circuitry which detects whether you're thinking about a situation where you've invested resources, and if so, pushes you to stay involved. I think this is inaccessible. I think it's inaccessible to figure out when you're thinking about your family, to figure out when you're thinking about death, to figure out when you're thinking about anything that's basically not a direct sensory observable, which actually like was a huge update for me. I was like, wow, okay, so how does any of this happen then, if we can't just say, well, the genome hard coded it? And so I think this is a really interesting puzzle that shard theory is, in one sense, trying to answer. I will note that there are a couple of dissimilarities between the case with the genome and the case with us as the AI designers. Evolution didn't just like, maybe if we could try running that like a really, really smart AI several times and figure out, we're able to shape the AI's behavior and like make it care about trees using our scheme. When we do this kind of approach, this might give us some information about whether we're able to actually access the AI's tree concept. So I think if you have several tries, this problem can get easier. But on the other hand, evolution was also not a consequentialist like we are. So it's not clear to me whether evolution on net had an advantage in tackling this problem. Now, I think I definitely want to pause here, because my understanding is that most people's primary specialization here is not already AI alignment. So I want to make sure that this at least roughly makes sense. Okay.
Sorry. Maybe I can jump in. Sorry, I'm on my phone still. Hey Alex, that's really interesting. So I want to know what you think about. So if you say the human world model is inaccessible to the genome, I guess what's really inaccessible is the very specific model of each human. But what's definitely accessible are sort of the broader circumstances on how things are encoded. So I guess so for example, I think there's Anthony Zador's work on how the genome encodes sort of, instead of like the specifics of the brain, how it encodes like the rules and wiring patterns. And this allows humans to sort of learn certain things very quickly. For example, languages. Like lots of other animals can sort of like imitate sounds, or they have the right physiology, but they can't learn languages in the same way. So I guess part of the world model is sort of encoded, meaning the sort of, for example, the ability to learn a language, whereas the specific language might not be encoded. Does that make any sense? So I just wonder about which level we're sort of talking here in terms of encoding from scratch.
So I think I currently take, my best guess is currently more radical than that, and that like I think that probably there's blessings of scale, of having a larger brain, of having regionally tuned learning hyperparameters. So like there might be like, so I think there's like areas where convergently just languages will be learned. And I don't necessarily think that the brain designates this is where languages are learned. And this is all kind of like an aside to shard theory. But one of my current guesses is like, look, given the macrostructure of the connectome and of how like where the optic nerve projects and so on, there's like a convergent way of learning concepts. So first of all, and like of arraying them in relation to each other, and this is what the functional areas are. So like first consider what it would be like if you had an edge detector and then like a square detector on the other side of the brain, and then like, I don't know, like a box detector for like the object of like a cardboard box or something. And then like if information had to be transported, this would be high latency. This is like the metabolic cost would be ridiculous. So I think at first there's if the brain is at all optimizing for energy and latency, then there's going to be like nearby computations will be clustered next to each other. And so then the question would be, well, where? And I think that given the like macro wiring of the brain, there's probably just a convergent place to learn edge detectors, namely in V1 and occipital, that the genome doesn't like designate here's where the edge detectors shall go, but rather like this is just like reliably where they tend to be learned, but with like a little bit of noise. Like my understanding is functional areas do differ somewhat across people. But that then this would suggest, well, there's a place where language tends to be learned as well as part of this like convergent learning chart. And that like over many iterations, there's like local hyperparameters that like the brain, like mutations were able to access and tune. So like if at first there's kind of a weak convergence of putting edge detectors in a V1-ish kind of area, but it wasn't very tight. And then if this were already the case, there would probably be local modifications which would tune the learning hyperparameters to make this like better for learning vision in some way. And then the convergence could sharpen as the computations clustered even more. I think this is somewhat supported by the 2000 Nature result with ferrets, where they rewired like the retinal inputs to or projections to go into A1 instead. And the ferrets learned edge detectors, but they were like in some way, I think, slightly worse than the edge detectors normally learned in V1, which suggests I think that's weak evidence for like hyperparameters tuned to each functional area. And so under that view, it's like, well, there's probably some combination of like learning hyperparameters for that are tuned for language, plus humans have a bigger brain, plus like attention guided by hard-coded circuitry that makes you pay more attention to data that's related to language for some like period in your life. I don't have like a firm stance here. This is just me babbling about my best guess.
Cool. Yeah. Thanks.
Yep. Does anyone else have a question or comment right now? Okay. So here is then given our second assumption about what I think is predictive processing, what in computer science we would call self-supervised predictive learning. My current picture is that this is where what we call like the human world model or like our abstractions come from. So that the point of this is the way this works is by locally reducing predictive loss and predicting either sensory observations like retinal activations or just higher level cortical activations like maybe a cat neuron. So at first a baby's born or is like in the womb and has very high predictive loss because by learning from scratch, it's basically randomly initialized cortical circuitry. Maybe that has like some predictors, like already like the broad structure of the predictors is wired up, but there's not really any information in how they should be predicting. And so everything is noise and everything is a misprediction. And so then there's probably some crude heuristics that could be learned that will immediately reduce this loss, these mispredictions, like well, just store what the previous sensory input was, like the previous thing I saw in my visual field, and then predict that the next thing will be the same. And if the baby isn't moving their head, this will probably be true for most of the visual field. And then like iteratively learn like more and more complicated abstractions. So like to predict like because things which edges on one have edges at one time still have edges according to your perception at the next time step. It's a good idea to detect when there's an edge, because then you can predict, there's going to be another edge nearby. And then maybe there's some like concept of an object, like, or at least of a ball in particular, because a thing which looks like a ball on one time step is probably going to look like a ball on the next time step. And so like by having this abstraction about it, it's easier to maintain and reduce predictive loss here. And then like learning translations, you have time t1 and then t1 plus 1. And then at t1 plus 2, the object will still probably be moving in a straight line. And so like if you had no idea where it would go next, that would just be a huge predictive error every time. But without even knowing much physics, you can predict like it'll basically keep moving in a straight line most of the time. And this will help reduce predictive loss as well. I'm not taking a strong stance on this is how this has to work, but I'm trying to illustrate here's a process by which I think there's like these convergently learned concepts and abstractions which are formed in order to reduce predictive loss under this predictive processing model. And eventually, another way to reduce loss is to have some idea of what's around you and predict that when you turn back, you'll see it. So like there's a water bottle here. And if I had like no idea, basically, like I'd get totally surprised whenever I turn to look back at the water bottle. But if I have some weak object permanence, like tracking there's a water bottle near, like outside my vision, then this is great for reducing loss. So I'm not constantly accruing these predictive errors. So I think this is also, like if I had to guess, again, not like super crucial for shard theory, but if I had to guess, this is where object permanence comes from. And that this process of iterated reduction of predictive loss is where the human world model comes from. It's where our ability to like intuitively predict the like proprioceptive outcome of moving our arm comes from, because if you're not making predictions about the proprioceptive inputs, then whenever you move, you're going to get a ton of error. So like being able to predict what will happen next when you yourself move, I think also comes from this, and it helps like lay the groundwork for later planning. And so I think, yeah.
From Lex? You have a question from Lex?
Yeah, sure.
Yeah, Lex, go ahead.
Oh, hey, yeah, I just asked in the chat. Is this sort of the same as active inference / the free energy principle?
I actually don't know. So can you briefly summarize that?
Oh, I'm still trying to learn about it myself. Maybe someone else in the audience knows a little bit more about it, but my understanding is that kind of like a fundamental driving force of organisms and intelligences in general is the ability to like have inference and observation as sort of a coupled process. Zach here says that his understanding is that it's a specific instance of predictive processing. So yeah, it sounds like what you're talking about. I'm not sure. That's kind of what I was asking about, but if you're not sure, then that's okay.
Yeah, I just answers I don't know in that case, but thanks for the explanation.
Yeah, totally.
Anyone else?
Yeah, so I guess I mean my understanding is pretty rough here, but I think that the way to think about it is like predictive processing is like a pretty general theory of how the mind might work, and active inference and the FEP are like specific theoretical accounts of how it works. So it's like just giving more content to a predictive processing account of the mind.
Oh, okay, that makes sense. That's cool. All right, that answers my question.
Yeah, so I think my current level of commitment is, it seems, or like the current level of commitment made by the theory is there is some self-supervised predictive learning process. Namely, you do stuff, you make predictions about what will come next, including about higher level cortical activations. And then whenever there's an error, you update to make the error less likely in some way. So I think there's probably lots of theories which are compatible with that rough description. Great. So now the reason I'm talking about why abstractions arise is because, or one picture of how abstractions arise is because human values, I think, form as a function of the concepts we can think in. And that's not necessarily the subvocalization like thought that you might hear in your head, but rather like abstractions as including things like edge detectors in B1 as like part of the language in which your activations speak, if that makes sense, is like just the set of either explicitly subvocalized or just implicitly learned and used concepts that your brain has accumulated. And that I think that this is very important, because if someone doesn't have an abstraction over, say, a lollipop, then they won't form a value about eating lollipops. And that this point is rather important for this next slide. So I want to think about a very simple case that, again, is not the prototypical, this is a fundamental human value, not for most people at least. But I think it's still a little enlightening. So there's a first point, which is what is going on with reward. And I'll mention this briefly. I'll go through an example of how I think it works, and then I'll talk about this more. That reward reinforces the computations that led to it. Namely, I think that people are not maximizing or trying to usually just trying to maximize their reward over time. This might be a component of what people care about, but I think this is importantly not the interesting part of the story in my worldview. So suppose there's some genetically hard-coded reward circuitry that takes as input outputs from the taste buds and from your metabolic state. And then if your taste buds detect sugar and you're hungry, let's say this reward circuitry releases reward. Now, again, I'm not committing to this exact thing existing, but I think it's good for walking through this hypothetical. So how might a kid come to care about lollipops in the sense of reliably asking for lollipops and ending up in features where they have in fact eaten a lollipop, much to the chagrin of their parents? So first, let's imagine a baby that has been doing some self-supervised predictive learning for a while. It's got some abstractions, but it doesn't I think at this point, babies don't really have any values to speak of because they don't know how to do anything. They've been learning how to predict the world, I imagine, but they don't have coherent movements that chain into plans with reliable outcomes, even on a very local level, like seeing something and grabbing it. So I think that this probably doesn't take super long, but at some point, maybe the baby there's a lollipop in front of it, and babies love picking things up, so the baby picks it up and then moves it and tries putting it in its mouth. And then it's sweet and the baby was hungry, and then the reward circuitry fires. So what happens next in this situation? Well, it depends on how good the baby's credit assignment is. Now, what credit assignment does is after a reward event, it tries to figure out what thoughts and actions were responsible for this reward being produced, and then upweight the responsible thoughts, and maybe improve them, generalize them, make the baby grab the lollipop in a slightly wider range of situations than the one which just happened. And so, but at first, the baby's credit assignment probably sucks. The baby probably doesn't have the baby probably doesn't even implicitly know how to, or subconsciously know how to pick out this, because I picked it up, that led to the reward. But at some point, the baby can probably do this. And so we'll just assume the baby's credit assignment is at least reasonable. And so then in this situation, the credit assignment will locate the decision to grasp the lollipop, those motor outputs, as in fact being responsible for the reward eventually being released. And this is true. And then moving it to the mouth, that was also responsible. So both of these decisions or thoughts get upweighted. And then, so at this point, the baby might have if I see it right in front of me, then this reinforced heuristic activates, and I just grab it kind of by reflex, not like a literal, what we'd usually call reflex, but in AI, we'd call this a reflex agent. Just reflexively, you see it in front of you, and then you pick it up and eat it. And then we might imagine another situation. So how do we generalize from this very narrow, if I see it, then I eat it? Well, imagine the baby is looking somewhere else, but it's got a little bit of object permanence in the sense that there's a lollipop that it knows is kind of just out of vision. And then the baby turns to look at the lollipop, which activates its existing heuristic. And then it does the sequence again. It puts the lollipop in its mouth, and then the reward circuitry fires again. In this case, the original decisions get further reinforced, finding or grasping the lollipop, but also to look at the lollipop when you know the lollipop's nearby, and then to locate it and put it in your mouth. So now when the baby knows the lollipop is nearby, the baby might turn to look at it and then put it in its mouth. And this can go on further. So if the baby happens to like probably can't like understand the word candy at this point, this is one way it could happen later. But also if like the baby could be like a little bit, maybe the baby's getting to like more toddler age, but the baby's like a little bit farther away from the lollipop, and the baby happens to crawl closer, and then it knows the lollipop is close, which activates its existing heuristics, and then it does the whole sequence again, and then it puts it in its mouth, and then the reward happens, and then the baby gets reinforced for crawling towards lollipops when they know it's like within some reasonable distance. So this is one particular way this could happen, but the point is, here's how out of basically nothing, out of like curious exploration and an ability to predict the world, the reward system can reinforce into existence computations which will reliably lead the baby into a world where it's eating a lollipop. And like this can become more and more broad, where eventually there's some amount of like what we might call planning going on, some amount of predicting the consequences of outcomes. And I can tell more specific stories, I think, for what happens here, but that like this is the kind of thing which later grows into a set of contextually activated heuristics that lead to the baby doing something that was downstream of past reinforcement from past reward. This doesn't mean that the baby is trying to get reward or trying to stimulate, or like the baby truly cares about stimulating its taste buds. The baby has, in this hypothetical, has some contextually activated cognition, which leads it to a future where it's eaten candy. That is what has been reinforced into existence in this thought experiment. And so, like basically my model of how people work right now is not that people have a system 1 and a system 2, and like the system 1 is like the subconscious fast and cheap heuristics, and the system 2 is like this explicit kind of planning. I think it's all heuristics. I think it's all heuristics of varying complexity, of varying like contextual activation. Like in a range of situations, you might engage planning to figure out like whenever you're hungry, you might just actually plan to find some food, right? That might activate some subvocalized planning cognition. It might be relatively sophisticated. I'd still call these heuristics, but importantly, that like the set of heuristics that is probably brought into existence downstream of reward from this sugar circuitry is probably pretty related, like related to lollipops and chocolate and some other foods. None of it is about the reward circuitry itself, but it's like kind of this what I'd call a shard of value. A set of contextually activated heuristics. So I think this is the type signatures we would say in computer science. The kind of thing that human values are, I think, is just contextually activated heuristics. Another example of this might be, at least for me, when I'm hanging out with my friends, I'm more excited about making plans with a friend when I'm hanging out with them. And so this is kind of weird if you think that I have like universally activated coherent preferences, no matter what situation I'm in. Why would I be more willing to make plans with them when we're right in front of them? And I think shard theory says, well, look, in this situation, like you have parts of you which are in some sense like value shards around your friend, and in the sense of activating patterns of cognition which were reinforced by past reward around friendship, and that these value shards will most strongly activate in the context in which they were reinforced, and that context is when you're hanging out with your friend. So I think that this view of human values as these contextually activated things is actually like importantly predictive, and has made me significantly less confused about like the way I work, at least. So these heuristics, they chain together, they bring about these outcomes. They are things which are downstream of past reinforcement events. And so, yeah, so my picture of what people are is that we are basically heuristics on heuristics that were chained into existence via somewhat sophisticated procedures, perhaps, but or by reinforcement events, basically. And that some heuristics happen to be introspectively accessible, happen to like render as English in our head, but that doesn't make them like genetically like pre-specified to like be extra sophisticated planning on my model. So this slide has had a lot in it, and I imagine people have questions, so I'm definitely gonna stop here.
Hal, do you want to repeat your question?
Sorry, did you say my name, Anna?
Yeah, if you want to repeat your question.
Yeah, it's just written in the chat. Alex, if you want to take a look at it, I'm asking, can you point more specifically at which bit of the whole lollipop reward circuit that you drew? Which bit is the shard? That wasn't clear to me exactly.
So the reward circuit is not the shard. Hold on. The reward circuitry is not what I call part of the shard. The shard of value is the set of contextually activated heuristics which are reinforced into existence by these reinforcement events caused by the sugar reward circuitry. And so I'd call those like the sugar shard, or like the lollipop value shard. Is the set of contextually activated heuristics or cognition patterns which influence a person's decision making, so that they're executing past reinforced thoughts, basically around lollipops, if that makes sense, that lead to them getting lollipops. So the shards are the contextually activated heuristics. So like if I see the lollipop in front of me, then pick it up and eat it. Like that's a contextually activated heuristic.
Right. I think I still have some questions, but maybe I'll wait for the whole presentation. I'll ask you at the end.
Maybe you could ask a question now, and I'll tell you whether it'll be answered later.
Sure. Let me try. Can you bring up the bullets? I don't see them yet.
Oh yeah.
Yeah. So in this case, so we started with like some sort of reward that fired when I put the lollipop in my mouth, and then anything downstream of that can become a shard. Is that more accurate, or still no? As long as it's contextually activated.
Yeah, so I think that sounds right. So usually, like I use shard as shorthand for a set of like of heuristics which chain together to bring about reasonably similar goals or reasonably similar outcomes, like of having a lollipop. And often these heuristics will have been formed by similar reward circuitry, I think. So in one situation, I might be like if I'm in a maze and I'm hungry, I might have some planning, which I might activate planning to like figure out, okay, I'll like use the left-hand rule, stay on the left wall of the maze, and then I'll reach the exit, and then I can like go to the bread store outside. And this would be from like, I don't know, my food or my hunger or whatever shard that'd be influencing my decision making, because part of the point of the plan is to go and get food. And I think that would be influenced as something I would call a hunger shard. And the reason I think that has substance is because like that desire to get like the planning to get food when hungry is not something that just like magically happens for free, but it had to be trained into my brain. And like where it comes from, I think, is reward around food events, and it forms these like contextually activated heuristics. If I'm hungry, then like upweight plans that involve me getting food.
Right. So I think that makes sense. Does that mean that shardiness is like a continuum where like certain kinds of heuristics that I can sort of play around with without like really feeling the reward? Like when I'm just simulating something and then I can sort of taste the reward, like let's say something really far away, like trying to get into a career or something. And then that also has like a career shard in it, but it's like less shardy and more planny. Like, is there a continuum here or no? It seems like there would have to be, from what I'm getting.
So I think that, so I first wonder, so you mentioned the reward as being an aspect here. Now, on my model, shards these things are contextually activated computations, which don't themselves require a reward to be activated or to be followed through on. So I think that if you just froze a person's reinforcement learning process somehow, you could just always make it so there's no reward prediction error or whatever. I'm not super familiar with the details of how that would work, but if we freeze the release of like unexpected reward, and I think this would, and then basically you're just executing the person's learned behaviors. That if there were no further reinforcement events, the current learned behaviors would just keep executing. So if you were in a situation where you were hungry, you would still go get food. You might not find that food particularly like surprisingly rewarding, but that a lot of your cognition would still execute the same way. Like I think if you had a pizza shard, this part of you might like would bid up futures where you expect to have consumed pizza, right? Where you think I will consume pizza if I do this plan. And then this does like even if you were not capable of tasting the pizza anymore, I think this part of you would like at least part of your pizza shard would still be like, yes, let us up, like I'm upweighting this plan and to increase the probability that it gets executed. And that a person could in fact choose to eat pizza without having any experiential reward for it. And this would still be like an action they'd execute, even though there'd be no reward. Do you feel like that interacts with your thoughts on this or no?
Yeah, if I'm imagining like removing the reward circuitry entirely, like you suggested, and maybe I should just to again reiterate on the continuum question. Like, let's say I have some contextually activated heuristics when I'm using a Mac OS and when I'm using a Windows PC.
Yep.
And now, do I have a Windowsy shard? Do I have a Mac shard?
So,
What's missing from this picture?
Yeah, so I think like I don't normally draw the lines this way because probably there's so first of all, there's definitely not hard-coded reward circuitry around Mac and Windows. Now I think there's more ways for reinforcement events to occur. I don't know how that works, or I don't think I have a good picture of how that works, of reinforcement events occurring as a result of yeah, this is going to get into an open question. So actually I've got this on a future slide and I think we should hold it for then.
Yeah, thanks.
Yeah, I don't normally think of myself as having that, but I think that would be, in fact, a reasonable thing to draw because you do probably have different contextually activated behaviors. You probably have like a hometown, like a set of hometown behaviors at least. I wouldn't necessarily call it a hometown shard, but like when I go home, I often like have some sense of being a different person or like acting in a different way, in a way that feels relevant here. But anyways, I'm going to keep going unless other people have questions they want to ask right now. Okay, so this process seems relatively simple. What I mean by this is, in this hypothetical, at least, the sugar, the hard-coded sugar reward circuitry wasn't some really complicated object that had to specify what a lollipop is. I mean, a lollipop is a pretty complicated concept. I bet philosophers could disagree for hundreds of years on what is really a lollipop, maybe. But still, like, people do, in fact, like kids do, in fact, end up liking a thing called candy. And I don't think there's like a complex candy detecting circuitry that detects when you're thinking about this complicated candy object and can tell if it's not really candy. This seems very unlikely to me. And that the symbol circuitry in the example will form this value around this complex real world object. And one of the reasons it could do that is because the baby had already done the work, or the child had already done the work of learning the abstraction of a lollipop, right? There could be like, if lollipop in front of me, and this in fact requires having the lollipop abstraction in your brain somehow. And so I think other human values form like this, that in this relatively simple way, that the human values themselves are complex, contextually activated, but they form in a simple way. And in fact, I think the picture I gave is basically standard reinforcement learning with self-supervised predictive learning on the side. It's not like this exotic human-specific feature. Now, indeed, we probably won't give AI sugar-based reward circuitry, but the general story, I think, is just relying on standard reinforcement learning over the responsible computations. So I think this picture might apply to some broader range of systems, including perhaps the AIs we actually build, which is exciting because it seems relatively simple to form values for these systems. Now, some things can be different, the inductive biases and so on, but I think this basic picture is pretty informative. And so there's this question of, does relatively simple pre-specified circuitry in combination with the environment reliably form these complex human values? And it seems to me like the answer should be yes here. There's some open questions like so if this picture is roughly correct, which reward circuitry forms which human values? For example, niceness, cooperativeness. It would be great to know why people care about these things. And in my language have shards of decision making around them. Another one is something I'm calling libertarian benevolence. Now, I don't think it's a value that most people have, but it's kind of a value that I have. And the reason so here's, I'll tell you the value and then I'll tell you why I'm thinking about it. So the value is something like, I don't have to share someone's preferences to want good things for them. Now, I don't need to enjoy baking cakes to want people to be able to bake cakes if that's what they enjoy. And so it seems to me like there could be some like core replicable value here, where even though we're not going to build another human, we're not going to build an AI which is basically like a really smart human that also values coffee and sex and food and so on. Like, I think that's not very necessary. But instead, we need to make an AI which cares about us, which is acting in our interests. And one way to do this is an AI which isn't necessarily nice, but it's like, here's some other agents that I want to cooperate with, and I want to just build a ton of Dyson spheres and give them a ton of compute and help them have control over their own future, whatever that's going to be. And I'm calling this libertarian benevolence. This is not like the thing that I'm set on, but it would be great to know how, in fact, this value formed within myself, because that is a thing which indeed happened, because I think that'd be pretty informative for possible ways we could form it within an AI system. Another question is, what's up with psychopaths? So there's one hypothesis I've come across which seems pretty interesting, which is that psychopaths are missing some niceness reward circuitry, or they have some like inverted reward circuitry, such that they get positively reinforced when they're being cruel, or negatively reinforced when they're being nice. Now, I don't, unfortunately, I haven't been able to find much evidence on this question, this specific reward circuitry question, or what's up with the reward circuitry more broadly. And also, it seems to me like thoughts themselves can be rewarding and not just a sensory stimulus. Like, I think about going and eating some really good food, or I think about how great it'll be to go on vacation. And then it seems like in the future, I'm slightly more likely to have this thought again, which implies to me that there's some kind of reinforcement event which occurred around me having this thought. But by inaccessibility, the genome can't just hard code thought rewarding circuitry. Like, I think there has to be something more going on here than my current picture of hard coded circuitry and then like human values downstream of that. So the question would be, well, what is going on here with thought rewards? And in particular, does the neocortex have write access or reward access to these subcortical reward structures? So I feel pretty confused about this broader picture of beyond these very accessible functions of metabolic state and of taste buds and so on, and of pain and such. It seems pretty obvious to me how we could have reward circuitry around that, but I feel pretty uncertain about the more sophisticated, what is our social reward circuitry like? Does it exist? And so on. So these are some of the open questions. And the shard theory of human values. This is the end of the talk that I had prepared, but I imagine there's a good number of questions. We'll dive into those now. Thank you.
Thanks, Alex. So yeah, I think that we can just people might maybe even speak up when they're ready, because it seems that there are not that many of us. Oh, actually, there are a few people. Okay, we have many people. So actually, Sahil, I think you were first, so feel free to ask your question.
No, I was just doing the clap emoji. That's often mistaken for a raise hand emoji.
Again, okay, the people are actually clapping. So, so anyone with a question, feel free to speak up. Sahil?
Does TJ want to go first?
So yeah, I think my question was basically would base level shards point to natural abstractions in the Wentworth sense of the term, and I'm curious also about if that is the case, then for the sorts of shards that are pointing to more complex things, like maybe cooperativeness or things like that, like, yeah, I don't know, like, do you think like the natural abstractions research program would also have to like extend to be able to talk about these complicated structures and stuff? Like, yeah, like what is the synergy between both of these research programs is what I think my question was.
Yeah, I feel pretty excited about the abstractions research program. I think that if natural abstractions is true in some reasonable forms, then we should expect that most things we form values around are also natural abstractions, especially given our data and our environment. I think that cooperation is probably a natural abstraction as well. Maybe not in the sense that John would use, but in the sense that I think about at least. Yeah, I think John might agree with me on this. Yeah, my model of John is agreeing with me on this, but real John might disagree. I think so. So I think this is a segue to another point, which I think is important. Very often in alignment, people will talk about, so we have one instance of inner alignment being attempted of this outer system trying to build, or an outer system selecting according to some criterion, namely evolution selecting according to inclusive genetic fitness. And then what happened? Evolution failed. Evolution built something which is not aligned with inclusive genetic fitness. People do not just exclusively care about out reproducing their neighbors or competitors or so on. They don't have any reasonable version of this as like a core value. So therefore, people draw the inference that it's actually just hard in general to solve inner alignment. Now, I think there's several problems with this. So number one, this is not the only instance of inner alignment failures, so to speak. Human beings, under shard theory, human values are inner alignment failures on the reward circuitry. The reward circuitry is reinforcing computations, which do not themselves end up primarily caring about reward. I think people care about many other things besides just rewarding experiences. And so like humans themselves actually comprise the bulk of our data on inner alignment and inner alignment failures. And I think it's really important and is rarely ever mentioned, or probably not really mentioned at all before Quinton's work. There's the second point though, which is why did evolution fail? And the reason evolution failed is because no one in the ancestral environment was thinking about inclusive genetic fitness. This is like a sufficient condition for failure. So if you consider some genome and some ancestral genome, and consider whether there are local mutations which make it more probable that a person thinks about inclusive genetic fitness, maybe just subconsciously using an edge detector level, like just circuit that is firing, that is modeling abstractly inclusive genetic fitness. There have to be, for evolution to select people into caring about inclusive genetic fitness, there had to be local mutations which would increase the probability of a person thinking about inclusive genetic fitness before a reward event, such that their thoughts about inclusive genetic fitness could turn into a value shard around inclusive genetic fitness. But if they weren't able to think about it at all, then there's no like selection gradient, and evolution couldn't possibly succeeded because like we already know that people don't get this abstraction for free. They don't get this abstraction for free in the same way that they get the box or square abstraction for free through perhaps predictive processing. So like I think this explains away the need for positing that inner alignment is just hard in general. It shows that at least some kinds of inner alignment is going to be hard of aligning the agent to some desired set of goals. But I think like the case is more optimistic for people because our concepts, our goals are around concepts of good form values around. So maybe the same is true for AI. That is a bit of a digression, but I think it's an important, interesting point that relates to this abstraction hypothesis.
So I have a follow-up question, which is slightly goes in a different direction. That is something like, so it seems to me that like it seems to me that, yeah, like maybe like the way that reinforcement learning converts rewards into policy is like something much more simplistic than what like maybe like it does not give us an adequate theory of how like different forms of intelligence would convert like environmental stimulus and rewards into things they value and things like they will continue valuing, etc., etc. And maybe like shard theory is trying to like find that systematic theory of like how selection environments like lead to different forms of like things that value things in the environments or something like that, right? And trying to build a systematic theory in a way that we can reason about what sorts of values will an advanced AI system end up having. It seems to me that like, yeah, so I agree that like maybe like in the alignment literature recently this has not been discussed, but I think like some things like these were being discussed in the early period when like people were confused about like whether instrumental convergence is even a thing, or whether like there would be something like model convergence, and like whether like when people used to claim things like, oh, like advanced systems will automatically have model thing because like orthogonality thesis isn't necessarily true, etc., etc. And that history of like the debate makes me then ask the question, how does shard theory like shine light on like orthogonality thesis? How should we reinterpret orthogonality thesis in the light of this or something?
So my model of Quentin is wanting to talk right now. I don't, actual Quentin, do you want to talk right now? I'm not sure if Quentin's even here.
Yeah, so
Okay.
your model of me is surprisingly precise. Okay. So like there are two forms of the orthogonality thesis. Well, there are many forms really, but there are two primary forms. One is the like very strong orthogonality thesis, which is not what Bostrom originally advanced, but which is occasionally like referenced, if implicitly, in some alignment thinking, where like inner values are, so maybe I should start with the weak form of orthogonality thesis that Bostrom, I think, did actually advance, which is that in theory, it's possible to direct arbitrarily large amounts of optimization power to any chosen objective. Like you can have some algorithm which does that, which like pursues random objectives to arbitrarily high levels of intelligence. And I think this is true in like the very dumb and uninformative sense that something like the no free lunch theorem is true, where the no free lunch theorem is true means that like no decision-making process, no decision-making algorithm can have better than random performance on a randomly sampled set of all possible problems in the space of possible problems. The issue with both the weak form of the orthogonality thesis and the no free lunch theorem is that the actual physical universe is not like randomly sampled from the set of all possible decision problems, and actual real intelligences are not like randomly sampled from the set of all possible intelligences. There are like lawful low entropy simple patterns in the universe which cause significant bias in the types of intelligences and types of problems that actually arise in reality. And I think that the strong form of the orthogonality thesis, which is claiming that like, which is making claims about the sorts of intelligences that actually arise in reality and saying that there's no particular constraints or strong exploitable statistical patterns in the sorts of values they form internally and how they optimize, and like whether optimization power has any correlation in reality with inner values. I think that strong form of the orthogonality thesis is quite wrong. And that, for example, if you have a powerful AI that is doing a bunch of problem solving to develop nanotechnology and doing a bunch of experiments and thinking about things very hard, like I think it ends up, most real world AI designs will end up with an AI that has mesa objectives / learned values around solving problems and around like coming up with new approaches. And that this happens even if you like try to start out with a pure paper clipping AI or an AI with human values or anything like that. And some of my intuitions for thinking this is that there's this very common pattern in many parts of reality, which we might call like economic internal organization. And this occurs in like microbiome, microbacterial ecologies in the bottom of the sea. It occurs in like the actual physical human economy. It occurs in like prediction markets. And the general form of this pattern is that there are like these specialized structures within the overall system that focus on achieving specific tasks and receive some sort of like reinforcement or reward or money or resources for doing their specific task effectively. And then these patterns like influence the overall system, or these specialized structures influence the overall system in ways aligned with the selective process that caused them to arise. And so I think that like in reality, values do evolve in accordance with like the outer selection process that gives rise to capabilities within a system. And so you see things like humans who are very good at science and like scientific leaders in the field typically like doing science, or the best artists usually like doing art, and that's not a coincidence. It's like evolution didn't sneeze our value formation process into it because it has some magical desire for humans to have human values. Like we have human values because the tendency to form human-like values was useful for our capabilities. So yeah, I think there are simple underlying patterns for why values evolve in the way that they do. And I think that some form or some close relative to these patterns will occur in most like capable intelligent systems in the real world.
So for example, one thing, well, let me see if I can extrapolate a little bit here. So one thing we might expect to be true of AIs, I think many alignment researchers would not currently expect to be true, is that you build an AI that starts off with, let's say, a very large, what we would call very large shard of value, or very large value around just making paper clips. And then in the course of the AI's cognition and activities and learning process, it will learn to terminally, what we would call terminally value its instrumental activities. So it would get good at building factories, and in the process, like reinforce contextually activated heuristics around building factories. And that by our type signature of values, the AI is like, and like I think by just the normal intuitive sense of values, the AI is like growing some kind of values around just making factories, even though it didn't start off doing that. And that this claim is not true for all possible AI designs, but for the ones we will probably actually use. Does this sound reasonable, Quentin?
Yeah.
Yeah. So I think also the claim isn't like our exact values were super great for capabilities, and so anything that's great at capabilities will have our exact values. But like that, this like structure of how our values form is useful. Does that also sound reasonable?
Yeah, and like my view of shard theory and of Alex's account of reinforcement learning is that it's like a sort of internal economy, with reinforcement being the mediator of who gets value or who gets wealth in this quote unquote economy. And like, I think this pattern occurs in many places, and it's not a reinforcement learning specific story. There are many ways you can end up with something that looks like an internal economy with internal specialization and distributions of wealth/influence according to capabilities within that internal economy.
Do you feel like this has answered your question, or do you have more questions?
This was helpful, thanks. I think like I have like one more question, but I'll go after Sahil or somebody else after that, maybe.
Okay.
So Sahil, go ahead.
Yeah, sorry, I'm still digesting everything I heard. Also thanks for the lovely presentation, Alex and Quentin. It was very clear. This kind of work gets me really excited.
Okay, glad to hear it. And also Logan helped put it together as well.
Oh, cool. Can you go back to the first slide? Yeah, so my concerns here, and I'm not fully sure how it impacts whatever facts or claims about shard theory. But one thing I often worry about is trying to generalize alignment strategies from looking at weak optimizers. And I feel like a lot of the claims here are well explained by humans being rather weak optimizers. I think you might have addressed this, but I would just want to hear your take again about this. Like the reason that ontological shifts don't really seem to disorient us is that we just tend to compartmentalize. Like you realize, okay, God doesn't exist, but you still act by mostly Christian values anyway, something like that. Or you believe QM in the lab, but even physicists don't really think about it outside the lab. And later on, you also talked about evolution getting several tries, which is also partly because we're very, very, very slowly misaligning with evolution. Like if we uploaded ourselves and, escaped into a transhumanist future, then we're probably not going to bother with the substrate of genes, I would guess. Yeah. And when I think about like reward isn't maximized, that's also because the thing isn't smart enough. Like, sure, you can talk about antecedent computation, exciters. I can't remember what he said. Reinforcers, yeah. So like if I'm thinking about a corporation even, which is often really, really insane and not very smart, money tends to reinforce the kinds of things that they do, the flow of capital. But like a smart CEO will also like really try to maximize revenue because they can see beyond. So I'm just yeah. So this is like a cluster of like the same question, I guess, which is that this seems to apply to things that are optimizing really slowly or aren't really very good optimizers. Yeah.
So the claim I'm going to make is that the strong optimizers we have been worried about in large part just will not exist and may not even be real. So like I think there do exist kinds of optimizers like AIXI, which will just wire ahead. Like they are literal reward maximizers, and they're very good at it. But we will not in fact build AIXI or AIXI-TL, its bounded version. And I think this is extremely important. I think usually when people think about strong optimizers, there's like, but like, what do we do for strong optimizers? So it's like, well, what do you know about strong optimizers? So like, consider yourself. Like humans are probably, they're like the strongest optimizers we have seen so far. Now, I think if you asked a person, so me, at least, I know I can introspectively access my policy to a large extent, which is very important. And I can consider, not perfectly because I'm not actually in the situation, but I can model myself in the situation and imagine, so if I could take a pill that would make me get a lot smarter, but then like not know how to define my values because I'd be trying to think about the whole universe in terms of the wave function, would I take the pill? And the answer would be no. I would not want to turn into an agent which starts failing at these things, an agent which wireheads. So therefore, like, because I am in fact controlling in large part my own intelligence increases. So like insofar as if I were able to increase my intelligence, I would not foreseeably do it in a way which messes up. So I don't see why like strong optimizers should be expected to predictably drift from their own values, or like why they should like not want to compartmentalize. Like I think that the thing that people do is actually very wise. Physicists should not constantly be trying to think about the world in terms of the wave function. It's not computationally tractable. It wouldn't be helpful in most situations. But if they have situationally activated heuristics where like quantum mechanics is somehow relevant, then yes, they should be thinking about it. So like I think it's actually a feature. I think we have there has been an initial picture that's like, utility functions are so great. They should be defined over the whole world model. And then if the agent updates the world model, it should redefine the utility function. And I think this is just wrong. And because it runs into so many problems and people don't. Does that make sense? So I think if people, the strongest optimizers we know, don't want to become stronger optimizers, or like I myself don't want to become a stronger optimizer who like fails at these things, then like an optimizer like me just wouldn't decide to do that and would decide to retain these good properties. I don't know where the inductive step is supposed to break, if that makes sense.
So can you repeat that last 3 lines again?
So suppose I start off with good properties and I start off like navigating these ontological shifts in compartmentalizing and like not wanting to wirehead at time 0. And then at time n, I still want to make sure I don't want to wirehead at time n+1. It seems like by induction, unless some like external thing that wasn't under my control impinges on me and makes me do it, like by induction, it seems like this kind of optimizer will just not want to wirehead. Now, there's several ways this could go wrong. The optimizer could fail at modeling a situation. It might not be smart enough to properly account for the ways in which values will drift, and it could accidentally become a wireheader. But I think like this induction argument is pretty strong. And it seems to me like if there's some threshold where weak optimizers become strong optimizers and it changes, I don't presently see it. Does that make sense?
Yeah, I think I'm inclined to disagree with the inductive argument, but I mean, what you're saying certainly makes sense.
Why do you disagree?
Well, I think the norm would be that you would run into a mess optimizer of some kind, and like value drift is really easy, and staying aligned, even as we.
Okay, so if I can just quickly mention, Alex is, like, by not wanting to wirehead, Alex is staying aligned with his mesa objective. Like, the values in Alex that prevent him from self-modifying into a wireheader are Alex, the mesa optimizer, like taking control of the training process so as to preserve Alex, the mesa optimizer's values. So like this is another disagreement that like shard theory has with a lot of common framings around alignment, where like mesa optimizers are often framed as this exotic risk that like jumps out at you from SGD in some strange way, but they're actually very common and kind of like banal, in my opinion. Like human values, all of those are mesa objectives, which are misaligned, as Alex described, with the base optimization objective of reward from like the limbic system or wherever it comes from. Does that clarify things?
Where does that preclude the possibility of a really powerful mesa optimizer that leaves us behind? Is that also part of what you're saying or not?
Yes. So
yeah,
like the inductive argument doesn't seem to preclude that.
Well, so like, yeah, I agree there's a thing that could happen. I don't see why I think it should happen. So like, I could also be like, this like giant meteor comes and hits me. And I'm not saying like, so like, obviously your argument is more plausible, right? Or it's like more related. I'm not trying to say like this is totally unrelated, but like, I don't see why I should think that this will happen.
Right. So also, I guess a related question is, so I'm actually really bullish on this idea of like value formation happens routinely. In fact, I've taken to using the word terminalizing in analogy with instrumentalizing, when an instrumental goal becomes a terminal goal. It's also part of the work that I'm doing with Abraham Dembski at the moment. So the question that comes up is, doesn't it run counter to corrigibility? Like if I am attacked by a bunch of values, like you described the factory example, if the AI is sort of being attacked, quote unquote, by all these values that are being formed, and then there's zero-sum resources, then it would really want these values to not pop up. And so value formation should be rare in, again, a sufficiently advanced optimizer that is extremely incorrigible. So is there also a claim like, oh, corrigibility is actually pretty natural that's going on in here?
Yeah.
Alex, do you want to take this? Or
yeah, so okay, so I think I'll take part of this and then I'll let you say more. I think that I currently my current attitude towards corrigibility is like, let's just like with the amount of research resources we have right now, we should not mostly be focused on that. I think it is pretty anti-natural. I think it's like instrumentally convergent for these different shards to not be corrigible to people. We might be able to somehow build, like, I think it's at least worth thinking about whether some people are the kind of corrigibility we would need for a second shot at building an AI. But it does seem kind of weird to me. And I'm not very excited about it, which is a big shift. Now, I think, but then there's a point about, well, would new values form at all within a really smart AI? And I think, Quentin, you probably have some things to say about that.
yeah, so I think that like forming new values does not automatically break your old values and does not like render you unaligned to your previous self. My like analogy for this is going back to the internal economy idea. Like intelligently regulated economies are not like totally opposed to immigration or people setting up new businesses or the like. And the reason is because like what values want to do is influence the real world in order to achieve various outcomes. And so there are two dimensions to this. For if you're like suppose you're a friendship value which wants to like spread friendship across the world, and you're part of some larger AI system which has a bunch of other values in it, and those values are like competing for control over the AI's behavior, so to speak. So from your perspective, like there are two dimensions that influence how much friendship you can spread across the universe. One is your degree of control over the AI, and the other dimension is the AI's total capabilities for spreading friendship across the universe, right? So it can be very much in your interest to allow a new value to enter the like AI economy, so to speak, because the new value will, of course, decrease your measure of relative control over the AI's downstream actions. But the new value can bring in new capabilities that increase the AI's ability to influence the universe in totality. So the friendships values net ability to increase the universe can increase even when there are like new competitors entering into the AI's internal economy. And if you look at like humans, we are not infinitely opposed to acquiring new values. There are, of course, ways that value drift or value change / evolution can go very wrong in humans. You would not want to form like a new value for murdering people randomly. But like moral philosophy, for example, if you're like a human who's learned a bunch of intuitive, common sense moral values from your childhood, for example, and you're now in a moral philosophy class and your professor is asking you these weird questions about moral philosophy and how should you answer them, you can be like searching for a new value that lets you navigate this new situation effectively. And you might consider, say, the original John Stuart Mill's form of utilitarianism, like happiness maximization. And you like initially as like your new candidate value to enter into the coalition. And what you do with this new candidate value is you like check its level of alignment with the members of the current coalition. You like compare its decision-making process and the actions it recommends in various situations with those actions that your current values would endorse in those situations. And so this mental process of like moral philosophy by counterexample is exactly the internal alignment / consistency over time that we'd want a AI to apply to the new values that it's forming in new situations. So like we do have a fairly straightforward process or capability to allow coherence over time, consistency of behavior over time, even in the presence of newly formed values.
Yeah, I feel like the two examples you gave are importantly different for me. Like the first one seemed more like some sort of negotiation with my values, where the second one feels like a discovery of what my deeper values really might be, and not to like.
Yeah, so I'd frame. Oh, sorry.
Go ahead.
So I'd actually frame them both as a negotiation. Like, the thing about your existing values is that they control your actions, and they also control like how you adopt new values. And so the way I conceptualize this is as there's a negotiation between your currently existing values and the new like moral philosophy value over the exact form that the moral philosophy value will take. Like the moral philosophy value offers the existing values a kind of like value handshake, where the moral philosophy value agrees to emulate or align with the decisions of the existing values on as many like areas of concern as you can evaluate, as your existing values can evaluate. And so in exchange, the existing values allow the moral philosophy value to exist at all. So there's this concern of like new values coming in and taking over the coalition. But the thing to remember is that the currently existing values coalition are in control of the value formation process. And they're in a very good negotiating position, so to speak, because they're like holding existence over as the thing that they can offer. And that's a very strong position to make. Like they're in an agree with me or die situation with respect to newcomers. And like Alex mentioned previously, there are ways that this process can go wrong if the AI or the human is like incompetent at properly evaluating the new values and their consequences. But I think we are far from doomed by default in this scenario.
Yeah, just to quickly say, I think I would still differentiate between negotiations that I resent and that are sort of protected by my own incorrigibility, and ones that I'm like, oh, okay, this is a valid argument. Now I see better. Like I would resist people adding values into me, but I would definitely invite a clearer picture of my own values. But yeah, maybe that's a much longer discussion. I did think that TJ had a question. So thanks so much.
Yeah. Yep.
Nora was before TJ actually.
What was that?
Then Nora was before TJ.
So I missed the first part of the talk, unfortunately. So like this question has a more than average chance of sort of having some fundamental confusion embedded, but you can tell me if that's the case. So the thing I'm interested in is something like simplifying a bit what you've been saying. What I've understood is that a simplified version of saying this is something like the way I engage, or like the way an agent engages with the world, and like sort of in fact sort of the empirical data it's learning about the world, that process itself is connected to the value formation process, and is like can come in a form of sort of a complexification of sort of value, from like I just crave sugar to like lollipops, to sort of even more abstract sort of a complexification and the abstraction of into these value shards. And and then I'm sort of two things I sort of want to just gesture at. One is like in terms of like implication for alignment, I'm like, does this imply something like in fact we need to pay attention to what tasks we set AIs to like do in the first place, because this will be tied up with what values they learn. And then I just wanted to sort of quickly say that bits of literature that I'm more familiar with, like in philosophy, there's actually also sort of some interesting overlap there with like thinking about, like, is it possible for like rational agents to like aspire for new values or aspire for different values? And I think there's just, I'm not going to go into detail now, but there's like, I think some interesting sort of conversation probably to be had between like how does this map onto some thinking that has happened in other places.
Yeah, I think so. There's one clarification I wanted to offer. I think that's a pretty good summary, especially for I missed part of it. Is I think actually the craving sugar thing would come later, because probably the baby doesn't even have a concept, or the child doesn't even have a concept of sugar, and that like the proximate thoughts will be around different things. But So I want to make sure I remember your questions. So yeah, what was your first question so I can hit it in order?
So just sort of wanting to check whether that seems right. Like that one important implication would be that like it matters a lot what tasks we give to AIs in the first place, because that will be sort of inherently tied up with what sort of values they form.
Yes, I think statistically, yes, this will be true. I just wrote a post that is very relevant to this, which is called "Reward is not the optimization target." It should be on less wrong right now. So the important thing is what computations are we reinforcing within the agent when we give it reward? The important thing isn't what is the reward function, except insofar as it affects the kind of cognition we grow in the agent, because eventually that's what we really care about. So I think the question of like what tasks do you train it on, what thoughts or what computations can be executing when the agent is on the task, what crystallizes into the agent's decision-making factors. I think this is like most of the ball game, in my opinion.
Yeah, and maybe a related question is something like in this story, the mechanism of the reward function is playing an important role. Like, I mean, in humans or human evolution, sort of, there's like there's just like some reward mechanism that is already given. But like, where does that come from, or like, do we have design choice over what the reward function looks like, which will like shape what the value formation process looks like?
So do we have control over the AI's reward function?
Yeah, I mean, we do.
Yeah.
But yeah. But like,
yes.
And like, how do you know enough about how to choose the reward function to get to specific values if you want to get to specific values?
Yep, I think this is like the big question of AI alignment, or like this is how I'd frame it. And it's not necessarily about reward. We could get to AGI different ways. But that kind of question of like, how does the supervision signal relate to the AI's values? It's like, well, if we knew how to do that, I think we would be most of the way done. So yeah, I'm not worried about like, how do I find a really like a reward function that'd be safe to maximize, or like, how do I make like AIXI give me good behavior? I think most of the ball game is informing these values properly.
Cool, thank you.
Yep, thanks. I'm going to be right back. So if people have more questions, Quentin or Logan can take that.
EJ, do you want to ask your question?
Well, I'll ask. So I think I have two different questions. I think the first question is, I think I've heard very similar theory about like value formation or value selection in another part of like alignment discourse, except that like in that place, like there's an extra argumentation step made. So like when people talk about like Drexlerian AI services model, I think they're making some similar assumptions about what sorts of like functions would we want the AGI to serve, and like there are certain ways in which you could like only certain forms of things would be selected for or would emerge in a training process, etc. Except like maybe there's a claim that like functional modularity could also imply structural modularity, and therefore like if you know the different shards, then you could just train different services for each of those shards, and therefore like you may not even need an end-to-end trained agent to come up with shards, but like once you find the right sort of shard that you want to like the right shard like configuration, like that should be your alignment target, like you could actually get like different modular AI systems to optimize for that or something. Does that make sense?
Yeah, so my thought is that you can probably do that if you were like significantly better at interpretability / AI training than we currently are. And it's worth moving in the direction of being able to do that. I think you do encounter like a very significant capabilities penalty if you actually do that, because like if you have a broad set of problems that you need to solve, you're never entirely sure of like what combination of modules you need to activate in what order in order to solve all the different problems that are in front of you, and even the problems that you can't see are in front of you. And this is getting into like and moving back to my analogy of like AI internals as kind of like an internal economy. Like if you try and select out, say, the defense industry in the US economy and like extract the buildings, the infrastructure, the people, and so on and so forth, and move them into a new location isolated from the rest of the economy, I think you substantially reduce the capacity of the defense industry to build weapons systems, because like even if you try and do a very good job of selecting everything that you think the defense industry is integrated with, those things it's integrated with are integrated with other parts of the economy, and they're like these internal connections that activate in very strange circumstances that you couldn't foresee in order to support the various functionalities of the defense industry, and there are different inputs and outputs and regulators and so on and so forth. And like you can never be certain of which other non-defense parts of the economy are relevant to what the defense industry is doing. And so when you like try and impose this conceptualization of the modularity of the system onto the fully integrated system and pull out the different specific component for a specific task, you're making assumptions about how it interacts with the rest of the system. And very likely those assumptions are going to be wrong in some cases, and you're going to miss like interdependencies that are important for capabilities in weird circumstances. And you're going to have like a bunch of modular components that are significantly less than the whole. Anyone else have any other questions?
Yeah, I have a super basic question. So I'm not familiar with this term shard other than like, just everyday discourse. Can you just like explain why you call it a shard theory?
So
Yeah.
there's a couple reasons here. Well, first, we thought it sounded really cool, but the second, one of the main reasons is there's Eliezer Yudkowsky has an essay called like I think it was about the God shatter of human values, and how one simple selection criterion of inclusive genetic fitness had shattered into humans as thousands of shards of desire. And so that had really stuck in my head, and also seemed mechanistically appropriate in terms of there being relatively related, contextually activated heuristics formed from like similar kinds of reward events.
Yeah, cool. Yeah, I like that etiology. That's cool. Thanks.
Sorry, so I had like another question, which is, so I think like to some extent, I understand the fact that like maybe like the way in which values will get selected for via some selection process would form like that there's some systematic way that you could like probably theorize it, predict it, recognize it, etc., etc. But there seems to be like a range of different AI risk stories, I think, which are, one would argue is that like once you have certain forms of optimization that is replicable, the only those utility functions survive that are physically most efficient to optimize. Like those utility functions would survive the selection pressure, only those which like physics selects to be like the ones that are most easiest to optimize in the world in terms of like whatever perception, action, control circuit you could come up with.
Can you give me an example?
So I'm not entirely sure like what would be the example here, but something like if you had a lot of population of different optimizers, which are all optimizing different utility functions and competing for resources, I think the argument would be that the one with most productive efficiency, the one with the most efficient ability to convert resources into its output, desired output, would.
So yeah. So if you have a range, so like one agent which likes bananas and another agent which likes apples, and if the apple one takes so long to compute, it's using up a ton of resources, then it'll get outcompeted by the banana one and it'll die. Is that an example?
Yeah, that's probably like one example. I think like a more general example would be it's plausible that, for instance, entropy maximizers are the most efficient objective function maximizer in the universe, and all like if when competing against entropy maximizer, like most other agents might like lose in their ability to convert compute into dominating strategy or something.
So
yeah.
I'll go. I think that like, first of all, an entropy maximizer would probably be very easy to trade with, and have values that are easy for other systems to satisfy. But like the way I interpreted this concern, or this class of concerns, is that is more along an evolutionary lens, where like say there's an optimizer that just wants to create copies of itself, or to just gather as much power and influence as possible, and that's its only value. And like presumably you might imagine that it would be better at gathering influence and making copies and spreading itself and achieving control over the future, compared to other optimizers that want other things besides that, right? Is that what you were asking?
Yeah, I think like, yeah.
Yeah, so I'm not very concerned about this class of outcomes, because like, I think what you're pointing at is evolution over optimizers. And like, the thing about evolution is that it's a super, super weak optimizer. Like, think about how long it took evolution to build humans, and in contrast, how quickly humans built like civilization, and then how quickly civilization is going to build an even stronger optimizer in the form of AI. So like in my mind, the entire story of human civilization has been like the process of a stronger optimizer supplanting the weaker optimizer of evolution, with humans like various internal mesa values. And similarly, like I expect that the story of the next few decades is the story of human civilization building an even stronger optimizer, which will mostly supplant human optimization in terms of controlling the future. And so I strongly expect this trend to continue, and that stronger and stronger optimizers will control more and more of the future, in comparison to like the weakest of all optimizers, evolution. And the way this might turn out, in like a mechanistic story for how this might turn out, for how like the power optimizing optimizer is defeated, is that like the other optimizers that want a bunch of different values like realize the obvious consequence of letting the power / self-replication optimizer seize all the power and self-replicate as much as possible, and they collude to like destroy that thing, or to constrain it, or otherwise save themselves from the obvious consequences of them not acting. And the reason that this strategy is possible is because those optimizers are indeed more effective than evolution at optimizing the future. Like humans are much better at cooperating amongst themselves to constrain other humans or other things, compared to like animals or insects or whatever. And I expect that AIs and that cooperation ability is a consequence of our intelligence and our stronger abilities to optimize. And I expect a similar thing, but more so from AIs in terms of their ability to cooperate to mutual benefit.
So I think I have like some conceptual disagreement, but maybe we could discuss that offline. Like,
also, I left a message in the chat. as well.
I want to discuss, I put it in the chat. I want to discuss some of the value negotiation stuff that Quentin was talking about, if you guys are hanging around.
Yeah, I think I'll hang around for a little bit. I think Quentin probably has thought about this more than I have. So you might just be interested in talking with him.
I think now might be a good time to stop the recording and maybe having a more informal chat after that. So thank you, Alex, Logan, and Quentin for contributing. Thank you, Alex, for the great talk. And I think that we will have more discussions based on this.